Hello everyone, and welcome to today's Deep Dive. I'm absolutely thrilled to have you here. If you've been working with agentic AI for a while, you already know that actually building the agent, well, that's really only half the battle. The real challenge, and our core mission for today's analysis, is achieving total, absolute control over these agents. We're going to look closely at some incredible material on deploying LangGraph locally, but more importantly, we're going to see exactly how to pause, debug, and literally change the mind of your AI mid-thought. It's going to be a fascinating journey into the raw mechanics of agent workflows.
Okay, let's dive into our roadmap for today. We're going from foundation to mastery. First, we'll set up LangGraph. Then we'll bridge it with ngrok. After that, we'll explore the human-in-the-loop concept, figure out how to use breakpoints, and finally, we'll get into editing AI states.
Section 1. Setting up LangGraph.
Let's kick things off with our very first phase, which is establishing that foundational working environment right on your local machine. Now, building agents locally is fantastic because it gives you a safe sandbox to experiment in before you even think about pushing to production. To get LangGraph running, there are a few absolute necessities you've got to have in place. First up, your API keys. You'll need your Gemini key for the AI model itself and your Langsmith key for observability. You're going to want to place those securely in a .env file. You also need Python and pip installed to grab the command line interface. But crucially, and I can't stress this enough, you absolutely must have Docker Desktop running. LangGraph operates by spinning up containers behind the scenes, so no Docker, no LangGraph. Once your environment is configured, and a quick pro tip here, if you're on Windows, make sure you double your backslashes when configuring your JSON paths so you avoid any annoying string errors. You simply run pip install LangGraph CLI, followed by LangGraph up.
And this brilliantly illustrates what happens next. Running that command boots up LangGraph Studio. Instead of just staring at endless terminal outputs, LangGraph Studio gives us a tangible, visual UI. You can literally see your nodes and edges, the exact path your agent takes from the start, over to the assistant, to the tools, and back again. It's really an API server and a visual debugger wrapped into one neat package, running securely on your own hardware.
Section 2. Bridging with ngrok.
Now, having a local setup is great, but what happens when we need to connect it to cloud environments, like, say, Google Colab? Well, for that, we use a tool called ngrok. You could think of ngrok metaphorically as a bridge. It takes your completely isolated local server, the one quietly humming along on your laptop, and connects it directly to the vast open internet by creating a highly secure tunnel. The setup for this is incredibly straightforward. You just download and unzip the ngrok executable, authenticate it right in your terminal using the token they provide when you sign up, and then you just tell it which port it needs to listen to. Since our local LangGraph API usually runs on port 8123, we type ngrok http 8123. Almost instantly, ngrok generates a public URL for you. You take that public URL, drop it directly into your Google Colab environment, and boom, suddenly your cloud notebook is communicating seamlessly with your local AI agent.
Section 3. Human in the loop.
Now, what's really interesting about this next part is that we're pivoting from basic infrastructure to our core technical problem. We've built the agent, it's running, but honestly, how much do we actually trust it? Imagine you've built an agentic workflow for a major financial institution. It's doing great issuing $20 refunds. But what if your autonomous AI agent suddenly tries to process a $1 million transaction? Would you want it to just automatically execute that API call? No way. Absolutely not. The danger of having entirely unchecked AI in high-stakes scenarios is just immense. We absolutely need a safety net.
And this is exactly where the human-in-the-loop concept comes in. It's the ultimate solution to our problem. It breaks down into three incredibly powerful capabilities. First, approval. We can actually set thresholds so that critical actions require a real human to click yes or no before the AI proceeds. Second, debugging. We get to review the exact execution history, find exactly where it might have hallucinated, and rewind it. And third, editing. This is the ability to literally modify the AI's internal state memory mid-execution.
Section 4. Using breakpoints. So to achieve all these cool capabilities, we need a literal, technical mechanism. We can't just yell stop at the computer screen, right? We have to code it. Let's contrast the two workflows. In a normal execution, the graph just traverses from the start node to the assistant, automatically calls a tool, and goes straight to the end. It's a completely closed loop. But in an interrupted execution, we deliberately insert a pause. The graph goes from start to assistant, and right before it hits that sensitive tool node, say the tool that actually transfers the money, it halts entirely. It just waits.
The way we tell LangGraph to do this is remarkably simple in Python.
During the graph compilation phase, when we use builder.compile, we just pass an argument, interrupt before equals tools. Or if we want it to stop before generating response, we use interrupt before equals assistant. This exact syntax acts as a literal stop sign, telling LangGraph exactly where to freeze its execution.
Let's clarify the resumption process, because it's pretty clever. First, the agent pauses execution right at the designated node. At this point, if you check the state using state.next, it'll show you the exact node it's waiting to enter, proving it hasn't actually executed yet. Second, the human reviews the state, either through that beautiful LangGraph Studio UI or just programmatically in Colab. Once the human approves, how do we tell the AI to go ahead? We call the stream function again, but we pass none as the input. Passing none is the key signal here. It basically tells the graph, hey, I have no new instructions, just proceed, and the agent resumes execution exactly where it left off.
Section 5, Editing AI States. Okay, so pausing for security is great, but what if we want to actively change the AI's mind before it continues? Let's set the stage here. Imagine our initial user prompt is simply multiply 2 and 3. The message goes into the graph, the assistant node processes it, and it prepares to call the multiplication tool with the arguments 2 and 3. But we have an interrupt before tools breakpoint active, so it pauses.
So the crucial point is, while the AI is frozen, waiting to multiply 2 and 3, a human steps in and realizes a mistake was made. We actually want to inject a corrected instruction. No, actually multiply 3 and 3. We need a way to slip this new information right into the AI's memory before we let it unfreeze.
Let's walk through the exact programmatic steps required to pull off this mind-bending trick. First, the execution is currently paused at the breakpoint. Next, we fetch the current state snapshot to grab the specific thread ID. Then, we use the incredibly powerful graph.updateState function. We pass it the thread ID of our conversation, and we inject the new message content. Because of LangGraph's add messages reducer logic, if we don't specify an existing message ID, it simply appends this new instruction right at the end of the state. Finally, we resume the graph by passing none. Let's see how this all comes together. What happens next? Well, the AI wakes up, looks at its state, sees the newest appended message, telling it to actually multiply 3 and 3, and updates its tool call accordingly. It executes the multiplication tool, and the final output is 9, not 6. We successfully intercepted the AI mid-thought, edited its state, and altered its final output without ever having to restart the program from scratch. Now that is total control.
We've covered some truly incredible ground today, from setting up local Docker environments and ngrok tunnels to freezing code with breakpoints and manually editing an AI's state mid-execution. These tools take you from simply running code to truly governing your AI systems. So I'll leave you with this provocative thought to ponder. How will you use human-in-the-loop to make your own AI agents completely controllable, secure, and error-free? Thank you so much for joining me for this analysis, and happy building.